So hello, my name is Sharona Saltzman, and I'm an AVEVA Business Select employee. I am excited to tell you about one of our most amazing university success stories, University of Davis in Northern California. UC Davis was the first major university to pledge carbon neutrality in 2025. Pretty large. UC Davis was founded in 1905 and has the largest campus of all the UC schools at 5,300 acres. There are 39,000 enrolled students, 24,000 faculty and staff, and over 1,000 buildings. 3 boilers with 425,000 combined high-pressure steam, 2 chillers with 18,000 tons of water, 5 million gallons of chilled water storage, and there's up to 9.6 million gallons per day of wastewater. In other words, UC Davis operates like a small city. So UC Davis was looking to the future with their new pledge. Here's what they decided would be the most impactful goals. Reduce energy, gas, and water usage, achieve carbon neutrality by 2025, optimize chilled water system, improve HVAC scheduling, retrofit district steam heating. As you can see, this was a monumental challenge. Their first steps were quite obvious: to install automatic lighting in the classrooms and labs and retrofit the older buildings' HVAC systems to improve insulation. But even after modernizing the facilities, UC Davis still fell short of its sustainability goals. That's when their team knew they would need help from a real-time operational data platform. Enter AVEVA software to the rescue. After reviewing UC Davis's goals, we knew what they needed: AVEVA System Platform and the AVEVA Pi system. At the end of my short presentation, I will show you a video where the UC Davis team discusses these powerful AVEVA solutions, how they were utilized, and shares the story of their journey. This is a photo of their control room where AVEVA System Platform and AVEVA Pi Vision are in use on their monitors. One of the challenges they faced was capturing and integrating all the data they receive from many different sources. These tools enable them to do just that. Just so you know, these dashboards are also available on their team's iPads, laptops, and phones, creating a collaborative environment that unifies their team, processes, and assets. Here we see a high-level overview of all UC Davis's facilities in Pi Vision. This dashboard allows us the ability to click into any building for more granular details, including KPIs. If you look closely, you can see there's a summary section with all the different building performance metrics. Using the Pi system, UC Davis now drives efficiency through real-time monitoring of its chilled water utilization. UC Davis was not only trying to reduce their energy usage, but also trying to use the energy at the times when energy in the market was cheapest. These graphs show how a comparison of before and after utilizing Pi data to train the operators. By running the chillers during off-peak hours, UC Davis was able to save on energy costs. As you can see in the post-training graph, when energy rates are the highest, their energy usage is low. Another initiative was to improve HVAC scheduling through occupancy data. The campus has a data stream with the number of Wi-Fi connections there are per building. They were able to use this data in the Pi system as a measure of building occupancy. These graphs illustrate how by using Pi, they were able to capture cooling cost savings through optimizing their HVAC system. The first chart depicts their HVAC system before using Pi. As you can see, the cooling system would turn on at specific times no matter who was in the building. The second graph illustrates how their HVAC systems would now only turn on based on building occupancy, which obviously led to significant energy savings. This graph shows how they've continued to expand their building square footage while still being able to decrease their energy usage. The black line shows how the buildings have increased in the area, where the blue line shows how their energy usage has continued to decrease. UC Davis's goal to reduce gas usage and grid electricity and count more on renewables is translated in this graph. After implementing AVEVA solutions and acting upon the accrued data, they now count on grid electricity to cover only 11% of their needs, which is huge. UC Davis's water results are shown here. They've already reduced the gallons per weighted campus user from 40,000 to less than 25,000, which is nearly a 40% reduction. This means they not only exceeded their 2020 and 2025 goals by optimizing their chiller and HVAC processes with PI and system platform. So through the use of AVEVA system platform and the PI system, UC Davis was able to capture all the relevant data, act on it, and achieve the following results. 46% reduction in energy use, a savings of $15 million, 62% reduction in gas usage from heating system retrofit, expected annual savings of $150,000 from chilled water optimization, projected savings of $197 million over 60 years from shift to low temperature hot water heating. Now sit back, relax, and hear for yourself from the team at UC Davis and hear about their journey to sustainability.
UC Davis has several big sustainability goals. There's the zero waste goal. Another goal we have is to be climate neutral in our operations for scope 1 and 2 emissions. And then we have a water savings goal to reduce our water usage by 36% by 2025. We've actually already met that goal. We have a system, pipes in the ground, that carry chilled water around the campus. And so there's a loop that brings the chilled water to these buildings, and then heat is basically removed from the buildings into that chilled water loop and then taken back to the chillers. And the chiller is kind of like a big refrigerator that transfers the heat out into cooling towers.
One of the challenges we face in a system like this is data comes from many sources. So being able to sort of integrate and make sure that all these data is coming to the same place is important.
Two main things we were doing as part of that chilled water optimization project. One was just to reduce the total amount of electricity we're using, and the other is to try to use that electricity at times when in the market it's cheapest. The reason that we're able to do that is because we have a large 5 million gallon tank that stores cold water.
Which acts almost like a battery. So what they can do is store the energy and deliver it when it's needed.
And we can basically store it and use the chillers when the power is cheap and then run from that tank when the power is expensive. That data is in PI, and then we have a fairly complex PI vision screen that shows the operator's recommendations for how the chillers should run, when they should run.
So each time we make these sequence of decisions, we are obtaining data from the system based on the process state, the weather, as well as the electricity market.
And most of those changes were achieved using AVEVA system platform. So those were controls changes that we made in that system. Is basically a controls project in that platform to save energy.
And also we deliver a more quality energy in the sense that we use electricity, for example, at the time when it is cheap, which basically means that it is being derived from more renewable resources.
In terms of final results, last year, this specific work with the dispatching of the chillers saved $150,000, 8 to 10% of the total cost of running the equipment that we've saved by doing this.
We undertook a small pilot project for studying and learning how can we convert our district steam heating system to something more efficient, and in this case, low temperature heating hot water.
The Big Shift project is a large retrofit we're doing to save a whole bunch of energy and also reduce our greenhouse gas emissions and energy usage.
And we currently use steam boilers, and what we're trying to do is get away from this fossil fuel use.
We pulled data from PI on buildings and their current steam and energy usage to help inform that design analysis. Because the water temperature will be lower, the temperature difference results in less thermal losses. That's going to have a huge energy savings for the campus.
So one of the things that's really exciting about Big Shift is that it's going to allow us to fully electrify, ultimately, the infrastructure that we have for district heating on campus.
Generally, it's easier to make electricity green than natural gas green. A pretty good strategy to achieve carbon neutrality is to basically start to electrify your natural gas loads and use electricity to do your heating, and then you can more easily green up that source of carbon through solar or wind or other sources.
You can't manage what you don't measure. It is really true in sustainability. We do a lot of sustainability performance assessment, and we also do a lot of data analytics on campus.
Campus has a data stream about how many Wi-Fi connections there are by building, and we've been able to get that data and put it into Pi and use that data as sort of a surrogate for occupancy.
We use Pi system data to educate the campus community about energy use in buildings on campus. We take the Pi data that's in our Pi system, the same data that the engineers use to save energy on campus and find opportunities to save energy, to educate the public about how much energy buildings are using, how they use energy, because it's different from a home or apartment that people are used to.
Having the occupancy data allows us to see when there are times when people aren't at buildings and the HVAC system is on.
The campus energy education dashboard is a map, and there are circles that are sized based on the building's energy use intensity. And what we're trying to communicate here is that different types of buildings use energy differently.
This data stream in Pi has enabled us to better schedule the systems and work with other systems we have so we can save energy and eliminate waste.
So the dashboard teaches them about how buildings use energy, but also gives them insight into what we're doing, how we're saving energy in buildings, and how this connects to our carbon neutrality. This team of energy engineers is funded by their energy savings, so they're always calculating the potential energy savings and the actual energy savings, and this goes to feed future energy projects. In 2020, they saved around $1.7 million. And since this team has been working since 2016, they've saved about $4 million on campus.
We're trying things, we're experimenting, we're very much open to a pragmatic, experimental, but always optimistic approach towards solving the problems.